Last lesson in Unit S, S10, area and perimeter of similar figures. Whenever it is going to say perimeter, that's going to be the easier one because remember perimeter is distance around, so you're adding all the sides together. So it's one dimensional, it's just length. But if you're talking about area, area is two dimensionals whenever you have like a base and a height. If you multiply those together, you get units squared. That means that it's two-dimensional. It's going sideways and it's going up and down also. So for perimeter, it's going to be probably easier than the area, but it's still going to be doable. So 5 yards is length. 5 yards is how long this one is. 4 yards is length, and it's how long this one is. Perimeter is also length. It's just lengths added up. So, so we have one dimension here and one dimension here, so you don't have to do anything special. You can just set it up. So we have 5 is to the perimeter of 1 as 4 is to the perimeter of 2, which is 20. So if we cross multiply, we have 4 times P equals 5 times 20 is 100. So we divide by 4. So the perimeter of 1 is 25. Okay. And it says, what is the perimeter of the larger pentagon? So you would have put 25 in that box. The perimeter of the figures below are similar. The labeled sides are corresponding. What is the area of the smaller square? So 9 millimeters is the length of this side. 4 millimeters is the length of this side. So that's one dimensional because it's just length. Area is two dimensional, and we want to find this area. So whenever that's happening, because it's two-dimensional, we're going to make the lengths two-dimensional. So what we're going to do is, so we're going to square both sides and put the areas underneath. Okay? In this case, it turned out kind of handy because 9 squared is 81 over 81 equals 4 squared is 16 over A. You could cross multiply and divide, but if this is 81 over 81, the fractions have to equal. So what would this need to be for this to be 1? It's going to be 16. The figures below are similar. The labeled sides are corresponding. So again, they give us length and they're talking about area. So you're going to square the lengths and keep the area. So 1 times 1 is 1, so that's going to be 1 over 5. 3 times 3 is 9, so that's going to be that. So if you cross multiply, 1 times A is A, 5 times 9 is 45. A is already by itself, so your answer is going to be 45. Look at this parallelogram. If both dimensions are tripled, then which of the following statements about its area will be true? Okay, so let's see if we can figure out. On this one, we're going to do the problem and then kind of get a hypothesis of what's going to happen every time we have this kind of question. So it says if both dimensions are tripled. So if I multiply this by 3, I get 12 carry the 162. If I multiply this by 3, then I get 15 carry the 127, 28, 285. Okay, so for the old parallelogram. How do you find the area of a parallelogram? Base times height. So I'm going to do 54 times 95. I'm going to grab my calculator. 54 times 95 is 5,130. Then I'm going to do it again with my new dimensions, 162 times 285. So 162 times 285 is 46,170. So let's put a little comma there. All right. So then the new area will be 4 times the old area. Well, if I do 5,130 and I multiply it by 4, 5,130 times 4, 20,520. That's not this, so it's not that. 5,130 times 9. 5,130 times 9. Oh, look. 46,170. So whenever each length is tripled, the area becomes 9 times bigger than the original parallelogram. I wonder how we could get 9 without doing the problem all the time, because that took us a little bit of time to figure that out. How do you think we could get 9 if both dimensions are tripled? And we're talking about area. What is 3 squared? Because tripling is 3, right? Is 9. There we go. So whenever we have the lengths and we triple them and then we do the area, we're going to just square what we're multiplying by, and that's how much bigger the new figure is going to be compared to the old figure. The figures below are similar. The labeled sides are corresponding. If the ratio of the pentagon's area is 1 to 9, so 1 to 9, those are your areas. What would W be? Well, remember, because these are lengths, we would square them, so W squared equals 3 squared. I put that there and that there. Now let's see what we got. There's several different ways that we can work this, but I'm going to pretend that you have no clue of what else to do. So we're going to keep W squared over 1. 3 squared is 9 over 9. If I cross multiply, 9W squared equals 1 times 9, which is 9, divided by 9. W squared equals 1. And then we square root it, so W is going to be 1. Because 1 times 1 is 1. So it would be 1 feet. Alright, the figures below are similar. The perimeter of each figure is given. What is the ratio of the side length of the smaller triangle to the side length of the larger triangle? Okay, so they've switched back to us. Perimeter is one-dimensional, and we're talking about side lengths, so we don't have to worry about any of the squaring. So all we do is 12, basically over 30, but I'm going to keep it in this manner because that's what they want us to write the answer in. And you just reduce, and 6 will go into those 2 and 5 times, so it'd be 2 to 5. If a triangle's height is doubled and its base is tripled, then which of the following statements about its area will be true? Okay, so this one's a little bit different because they're not being done the same way. So what we could do, we could just come up with some rectangle. Doesn't have to be fancy, okay? It doesn't give us anything about a triangle's lengths or sides or anything like that, but we could come up with it. Let's say that this triangle that we just drew is 1 and 2. Well, what would the area be? Base times height divided by 2, 1 times 2 divided by 2. So that's going to be a 1 for the original one. But let's say we do what it says. The height of the triangle's height is doubled. So I'm going to double this, so I'm going to get 2. The base is tripled, so I'm going to triple that, and I'm going to get 6. Then I'm going to find the area again. Base times height divided by 2. 2 times 6 divided by 2. And we get 6. So compare 1 going to 6, and 6 is 6 times bigger than the first one. You could have done that with any triangle. It did not have to be 1 and 2. Everything, any sides that you come up with, still would have been 6 times. The figures below are similar. The area of each figure is given. What is the ratio of the side length? So we're going to, there's a couple ways that we could do this. Let's reduce this first. Just 2. 2 goes into both of these, so I'm going to reduce them by 2. But this is still area. This is still area. And I want length. So what are we going to do with length? We're going to square root both of those. So it's going to be 4 to 3. Look at the circle, the radius. If the radius is doubled, then which of the following statements is about its area is true? Again, for just one length, we are doubling it. So we're doubling a length. So its area would be whatever we're doing to it, which is doubling. So it's this 2 right here. And so we're talking about the area. 2 squared is 4. So it's going to be 4 times as bigger as the older one.